viewer, welcome to my YouTube channel. So this is a question on structure 3. This is a Clapeyrons theorem or the moment theorem. So this question is from structures, those who are doing civil engineering and building. So this is a question. I did it. These are my workings, so I'm going to go through it slowly and working. So the question, this is the diagram. Question says analyze this beam using the Clapeyrons theorem of the moments. Okay, this is the diagram. This is A, B, C, D. It is a fixed beam on this side and it is overhanging here. So this at AB we have a point load of 72 and distance of 4 meters. And then at BC we have distributed load IUDL of 24 kilonewtons and distance of 5 meters. So when you find a question like this one, it is overhanging here. This at the end is overhanging. So the first thing you do, you find the moment at C. You find MC because it's overhanging here. Find MC. Find MC. Take the load. This load times the distance. Load times distance. So this load times its distance, we get 30 kilonewtons meter. Okay, and before we continue, we have to know how many number of moments to be found here. Here we will be going to find the two moments here. We have the first moment here, the second, yes, moment A and moment B. Then how many questions are we going to get? Number of questions that required. Then we have two questions again. We're going to find two questions. So let's continue. So the first thing, we start on this part. Okay, so the first thing, we isolate this part AB, and when you find that the one side of the beam is fixed, the first thing you do, you form an imaginary part here like this of A naught. So this imaginary part, it will help you to calculate to find the equation of this first equation. So okay, so since support A is fixed, make an imaginary span A naught A of length L naught on left of side, this left side, because it is fixed. Because it is fixed, it's only, you can only form an imaginary when it is fixed. Understand that? So this part here, it is fixed, so we form an imaginary part, an imaginary span of A naught A. Then we form this one. The distance here is L, because it is imaginary, it is not real. The distance here is this distance 4 meter here, and this we have this part 5 meter. But now we want to get from imaginary part up to here, so we isolate again this. So again we isolate this part, A naught A, you draw it, A naught A B. Okay, so the L here is O, which is 0, and this is 4, here 2 meter and 2 meter, 72 meter. So the first thing you did, you calculate the area. The area of this part, this one, it will form a triangle. When this part is not ideal, it will form a triangle. In the moment diagram, it will form a triangle. When it is not ideal, it will form a triangle. So this triangle here, the base of the triangle, it will be 4, and this height is 72. Why 72? Because this, the formula of calculating this one, this is a freehand moment. The formula of calculating freehand moment is here. We have W, this force, times L, which is distance, over total distance. We get 72 kilonewtons. Okay, this one, it will be our height. Okay, then we use this height to calculate, to find it here. This one will be height and this one will be base. 4, it will be 4 here. So we calculate it, half base times height. This, remember this height, it is not the distance from here up to here, it is a force that we calculated using this formula. So this formula, we used it to calculate the height, this height here. So after that, we got this one, and then area is equal to, then 2 here, 2 here, then what will be 144. Then after that, we are going to get center of gravity, or x bar. So how to get we get x bar by taking the a plus L over 3, or a b plus L over 3. Now here we have a to be 2 and L to be 4 over 3. It will be 2. Okay, that's how we got these 2. Okay, again here b is equal, it's the same, because it is 2 2, again with 2 4 3, it will be again 2. Okay, now after we have gotten the area, we have gotten this, we have gotten the center of gravity, or bar, x bar will be 2. Now the next thing we do, we apply applying theorem of 3, moment in spans A naught, A and AB. So this is the formula. This is not the original formula. We have the original formula. This is the formula that we take this formula from the original one. So here of MA L plus this one. Let's go. So here MA we have, this distance is 0 because we just created it, so it is 0. Then we have 2 moment A times L, it is 0, the distance is 0, plus L1 is this distance here, it is 4, then plus MB times 4, this distance is 4, L1 is 4, is equal to 0. This part becomes 0 because of this one, this distance is 0, so this one divided by 0, it will be 0, then minus this one, area 1 we got what, 144, this area here we got 144. Okay, and then 144 times naught on the right, center of gravity on the right, this part here we got what, 2, the 2 here, then we divide by that, then we multiply this one by this one, it will be 8 plus this one 4b, then this one will be this. Then this is the first equation. So this is the first equation. Our equation are supposed to be 2 equations. So this is the first equation. So this is the first equation. I'm going to get the second one. Okay, at the second one we go to span AB and BC. Second one. Let's go. Okay, so this is span AB and BC. So the first thing, so we calculated the area of this part. It was 144, and then we find the uh, center of gravity at the left side to be 2, because it is this part is a plus L over the rate will be 2 plus 4 over the rate will be 2 again. So this part is 2, center of gravity is 2, 2, and this is height. So then let's come to this. Let's calculate this area of this part. At the radial, it will be something like a semicircle, and the formula of this semicircle to find this one is 2 over the times 5 times 75. 75 is the height. How did we calculate this one? They were calculating this one. This is the formula of calculating this one. This is a WL square over 8. W is this radial times L, this distance, square over 8. So this is the formula of calculating this BC. This one, and we got what? 75. Okay, and we got 75. After that, let's calculate the center of gravity of this part. The center of gravity is just 5 over 2. Here we divide by 2. On this part we divide by 3, and this part we divide by 2. Okay, this triangle divide by 2, divide by 3, divide by 2, 3, 2. Let's go. Then, so the first area is this one. This center of gravity at the left is this, and the second area is 250, and the center of gravity at the right, that is here, is 2.5. After 5 divided by 2 is 2.5. Moment at C, we calculated to be that negative 30. This part, the part that was here, it was 15 here, it was 2 here, with that. Then after that we applying the theorem of the moment span in AB and BC. So we use the normal formula because we have not created the imaginary part. So we use the normal formula here. So the normal formula is MA L1 plus 2MB open bracket L1 plus L2 close bracket plus MC L2 is equal to 6 negative 6 close bracket area 1 center of gravity left plus area 2 center of gravity right over L2 by L1. So it's the formula. So we use this formula. The first part M1 times L1 is here is 4. L1 is 4. L1 is 4, so it's 4 here. 2MB 4 plus 5. This part is the distance here is 5. Distance here is 5. Okay, so we take it to be 5 plus here is negative 30. Negative that because we go to 30. You can remember we go to that here. We go to that here. This part, go to that. Okay. Now, so this is 30 MC, which was 30, negative 30 times 5. L2 is equal to negative 5. Negative 5 as you can see. Then divide by 6. Negative 6. I've just opened the bracket, so it's here for 144. Area 1 was 144. Center of gravity left, which is on a triangle, which is 2 minus over 4L1, which is 4 minus 6 times area 2, which is 250 times center of gravity right in a semicircle, which is 2.5 over L2, which is 5. Then after that we created the second equation. Okay, we created the second equation, become E is 4 8 negative 15. Take it this way, then it will become positive. Then this is we created the second equation. After that, we have two equation. Okay, we go to equation. So this is the first equation, this is the second equation. After that, we solve this equation. I think everybody knows how to solve this equation, these two equations. We can use simultaneous equation or substitution, because they are two sides simple. Then after solving, we got the first equation to be ma is equal to negative 2.85, mb negative 51 point negative 51, yes, negative 51, and this one, and the last one mc was negative 30. And after that, we draw the diagram. Now after doing all of this, we should draw a diagram. So the diagram becomes this way. So we find the height to be the height of this one to be 72. I've told you the formula of this one is L of 4, and the formula of getting this one is this one, and the formula of getting this one was 8 square over 8, so that we can get this one. This is W is here, W is here. After that, then you draw it. It's a positive because the sign are positive. We got positive values, and then at here, the first one it was a negative, so this value are negative, so it's a negative, and we draw it going upward. If it is a positive, we will draw it going downward. Okay, so it is a 51, 2.85, 30. So this one is a negative. We go this way, and this is the working of the Riemann diagram. So this is the first. So we started here. We started here going downward. So this is the working. Then we come to this part. So thank you for watching. Please subscribe to my YouTube channel and like.